Hello and welcome everyone. Thank you for joining us for our expert sessions. These are short webinars which take place once every 3 weeks and last no more than 30 minutes, bringing you valuable insights from industry experts. Today's session will be presented by Sergio Panetta. He's a VP of Engineering at I-Gard Corporation. Sergio holds a master's degree from McMaster University with more than 4 decades of experience in electrical engineering, switchgear design, commissioning, troubleshooting, power system protection, and power system grounding. Sergio continues to actively raise awareness of electrical safety worldwide. A senior member of IEEE, a member of the IET, and he has been awarded consulting engineering status with the PEO professional body. We are excited to have him here today, and we appreciate your participation. Without further delay, I would now request Sergio to take over from here.
Thanks, Devansh, and welcome everybody. Good morning, good afternoon, wherever you're from. We're going to discuss load banks um, and system testing. So we're going to go through the agenda, introduction to load banks, purpose of load banks, types of load banks, operation, design, wet stacking, auto load leveling, data center applications, and go through some of the standards for testing healthcare facilities and battery testing. And we're going to answer some questions. So basically, a load bank simulates electrical loads to test power sources without connecting them to their actual operational loads. So if you have a generator or a power source like a UPS and you wanted to test it under full load conditions, you would probably use a load bank because you can't really simulate the loads unless you can guarantee that there's going to be constant load on the source at all times. So if you look at some of the testing requirements, which you're going to see later on, some of these test requirements require 3 hours of testing. And you may not be able to guarantee that you can maintain 3 hours at a certain kVA or kilowatt. So that's why you need a load bank. And you have to do it according to NFPA 110 and some other standards. So the other thing you could do with a load bank is simulate load profiles for batteries, for motors, for charging, discharging batteries, AC and DC. It gives you a lot of flexibility that you may not necessarily have in real life. But you're trying to simulate real life, but in a controlled environment. Load banks play a crucial role in commissioning of electrical equipment and ensure power sources function as expected under real world conditions before they're put into service. So basically, you're going through the motions of a load and testing your source in all possible examples. So sudden drops in load, increases in load. How is your power source going to react to this? And some of the standards that we're looking at later actually look at this. You can have AC and DC type load banks. So for AC, it could be three-phase, single phase, three-wire, and DC. So the purpose, the commission, the validation. So obviously you're going to run your power source. Let's assume it's a generator. You're going to run your generator, ramp it up to a certain load, and you're going to start timing because it has to maintain a certain power for a certain amount of time to be validated. And you're going to do thermal testing. Some areas require you to test the HVAC and the cooling system of a facility. So you can use load banks to determine if the cooling system is good enough for that facility. For example, we can put in a load bank to simulate a load. So not only we're testing the power source, we're creating heat so that you can test another faction of the building operation to ensure that the temperature is suitable and the HVAC system is suitable to cool that area down. This would happen in data centers. So before you start putting all your racks in, you can actually simulate that you're going to put out so much heat and the HVAC system has to maintain a certain load or maintain a certain temperature. And load banks can be used for that. Backup reliability, identify weaknesses in the standby power system under controlled load. Nothing is worse than Having your grid go down and switch over to backup generation, only find out that it can't pick up the load, and we've been through that, so we don't want to go through that again. Generator protection prevents wet stacking in diesel generators. NFPA 110 is the compliance for emergency facilities to have backup generation, and battery capacity testing is ISO 8528. You can actually pick up loads, drop off loads, and see how your batteries react to that. So again, we have the AC and DC type load banks. AC can be three-phase, can be single-phase, could be single-phase three-wire or single-phase two-wire. It's endless amount of possibilities that you can have. You can have three-phase Y-connected loads, three-phase delta-connected loads. The source doesn't care what kind of a load you have. It just wants to see a three-phase balanced load. So you can have resistive load banks, inductive load banks, capacitive load banks, and reactive load banks. Obviously, resistive is going to be pure resistive load. It's going to be unity power factor. Once you start to put in inductance, you can actually vary the power factor and put the generator or power source through its courses and go from 0.8 power factor through to unity power factor and see if it's sufficiently suitable for use in all of those conditions. Capacitive, you can put in capacitive load banks, although I don't think you're going to test it in leading power factor, but you can if you want to. DC, you can have constant current, you have constant voltage, and you can have electronic load banks where you would rectify a power source and switch a single resistor with multiple timing sequences and have a more programmable function. So the operation, load bank operation, load bank draw power from a source. Again, your source could be not solar, but a solar converter, a solar bank. You can put a load on a solar bank and find out if you can take the load of the solar power, make sure everything is good. Batteries, you can discharge capacitors through a load bank. You can have a generator, so a three-phase generator. So in this particular system, this looks like a data center. So you have where is it? Where are the racks? So here's your battery backup room over here. So you can test the load of your battery backup room. This looks like generators here. This is your power distribution center, and it looks like you have racks someplace. So I guess these are the racks over here. So you can simulate the racks to make sure that the HVAC is working, and you can also test the generators here and your DC backup power. Test applications used to test stress test power. Again, you're going to put your power source through some severe power profiles to ensure that it can react under any particular load profile and make sure that it's going to be stable, because you can the most famous type of test is a load rejection test. So what happens when you have a load rejection test? You have a lot of load, you shut the power off, and what happens to your power source? Can it maintain that? Load is applied through routing current through resistor or other loads. Obviously, this is a load bank. Heat removal. Again, we're going to test the heat produced by the load bank to make sure that your HVAC system is working. And right now we also have liquid cooled load banks, because a lot of the data centers might be converted over to liquid cooling instead of air cooling. So if we take a look at the circuit over here, you have a fan, because you're basically, this particular load bank is putting out as much as 250 kilowatt at 50 kilowatt resolution steps. So if all the steps are on, these are the load steps here. We have 3 load steps. It's very simple load bank fused in your bus. So basically, you can have 250 kilowatts, so you're cooling down the resistors and creating heat for other types of devices to test. And your controller. So in the last session, they asked if your controller can be hooked up to a SCADA system. Yes, it can. All you have to do is we can provide the contacts here. You just tell me what voltage you're going to come in with to control the load banks, and I can provide those contacts to make sure that this thing is going to function through your SCADA system. And while you're doing this, you can measure the output temperature and measure the stress on your HVAC system if you wanted to go through that. So this particular load bank has 50 kilowatt resolution. We can go down to 5 kilowatt resolution. But now you just need a smaller contactor and a smaller fuse. So you don't want to go too low because, if you have a 2 megawatt load bank, you really don't want 1 kilowatt resolution on it. So you have to be practical about this. Cooling functions. Obviously, you have a blower motor, and it could be, depending on the load bank, you can have multiple blowers in there. You have overload to protect the relay, fuse protection, and a starter. We have load banks with internal power and some load banks with internal and external power capabilities. So if you wanted to test single phase power on a 3-phase load bank, you can do that. You just need to worry about providing 3-phase power to the blower so that you could maintain the cooling of the system and not overheat your resistors. We obviously have backup protection on the blower because you want to have airflow, make sure that the air is blowing across the resistor, and pressure differential across the resistor to make sure that everything is working properly. And sometimes you can have these things outside, so we'll have automatic dampers on them, so they'll close automatically, open automatically, and start to function. Load element is basically a resistor. We can have many, many different types of resistors here. Every manufacturer is going to have their own element that they use. You have basically the main input. The main input could come in via cam locks or bus bar if it's permanently mounted. Cam locks typically are used for temporary load banks so they can be quickly connected, tested, disconnected, and shipped back out again. Load contactor selects, turns on the breaker, so it turns on the contactor to put the resistive load onto the bus. And you can have one of these for each individual step. So if you have a 2 megawatt load bank, you can have 20 steps, or you can have 5 steps. Depends on the resolution you have. Power distribution, main bus bars are used for quick connection. We went through that. Control circuit, every single individual resistor is protected by its own fuse. Again, those can be Y connected or delta connected loads. They act the same. They perform the same. It's no difference. It makes no difference to the power source whether they're Y or delta connected. So we have wet stacking here. Basically, diesel generators running at low load fail to reach proper operating temperatures, causing incomplete fuel combustion. I'm not sure what this graphic means, but basically it says if you don't have the right temperature, you may not necessarily have the efficiency that you need coming out of the generator for it to work optimally. And we want it to work optimally. So to make it work optimally, we put we try to maintain a 75% load on the generator so that it's running efficiently. So we do that by applying more load depending on whether the plant load can actually be sufficient enough to maintain the 75%. If the 75% isn't achievable through plant loading, we will put in a load bank and have it auto leveling so that when the load drops below 75%, we add more load on the load bank to make sure that we maintain that 75%. So if your load on the plant drops to below 50%, we would add 25% on the auto leveling system as long as it's under the capability of the load bank, which is all you need to worry about. So what we need for that is we put a CT on the plant side so that we can monitor the minimum plant loading and compensate for the maximum for the load bank loading to ensure that we have a minimal load on the generator to ensure that it's functioning properly. If you don't have incomplete fuel combustion, you're going to get a lot of carbon buildup, and it's not going to make the generator run efficiently. So having an auto leveling load bank will have more efficiency and lower your maintenance costs on the generator. Well, on the engine, basically, not really the generator, but the engine. So this particular customer wanted us to put a load profile that looked like this. So this time here was variable. This time was variable. This step was variable. So with an HTTP page, website, we put it into the load bank, you put in all the parameters, and it would be running along, and this is your minimum baseline. So if the generator wasn't running at this minimum baseline, the load bank would turn on to increase the load so that it reaches this minimum baseline. And then every once in a while would boost up to 30 kilowatts for a short time and then come back down just to decarbonize the output. Again, it was their design. We just complied. And again, everything was done through a URL on the load bank to determine everything that you needed to do. And obviously the relay output statuses were here, so you can turn on a 2 kilowatt. You should see the 2 kilowatt come on here. So data center applications. So here are the racks, the servers. So you can simulate the heat on these servers, ensure that the HVAC system is working, because they're not going to put all this stuff in here to make sure that the HVAC system is properly balanced unless they determine that it is properly balanced before they put in the servers. Generators over here, distribution center. I don't see the battery room, but it's in here someplace. Your grid goes down, you want to make sure your generators can pick up. And the generator should pick up faster than your UPSs should tail off. So testing backup generators, crucial, because we've had power failures before where backup generation just never picked up. Verify utility grid connections. If your utility goes down, the generators have to pick up. Your UPS should help you right through that. Load test distribution panels. All these distribution panels over here, they're going to be load tested, and you simulate the server rack heat system. So it's many functions. In one data center, you're going to have many functions of the load bank. So NFPA 110 compliance with healthcare systems. So a monthly exercise of a generator is to have a minimum of 30 continuous minutes at greater than 30% nameplate capacity. You have a 100 kilowatt generator, you have to have minimum 30 kilowatts on it. So for 30 kilowatts, you may not necessarily want to exercise your ATS, although I think you should do it every once in a while, but I don't have that section in here to see if that needs to be exercised as well. Annually, you have to have 50% of a nameplate for 30 minutes and then 75% of the nameplate for 60 minutes. This could all be programmed into the load bank so that it does it automatically. 36 months test, continuous 4-hour performance. So you have to put the 4-hour test on the generator with the load bank. And then we have records that you can download to ensure that everything is done. So you can ramp up to, for example, annual test, you can ramp up to 50%. Once you're at 50%, start the timing. You're there for 30 minutes, ramp up to 75%, stay there for 60 minutes, your test is over. But you have to test the batteries too. So there's a lot of battery backup systems on these, for example, UPS rooms. The data centers have a lot of batteries. There's a lot of BESS facilities out there. Solar panels all have DC. So International ISO 8528-5 standard defines strict electrical response ratings for class G1 to G4 during sudden load changes. So if you have a load rejection or a sudden step change, how is your source going to react to that? And if you look at 8528, you can verify that you have completed that or stressed your power source to that. Battery discharge diagnostics. You can look at your battery discharge rates and see if they comply with the manufacturer's recommended practices. So this particular load bank is 600 kilowatts. So we have a fan over here. Here's my load. All the contactors are on top. This one's a 240 and 480. So we have we can put out the same output at 480 as well as 240, individually fused. Control panel over here, and I know it says 350 there, but 350 and 600 kilowatts are almost the same size. Any questions? Any questions? I know we went through that relatively quickly. Can we test generators with real load without having load banks? Yes, I guess you can, but you can't really guarantee. For example, if you go back to this screen here, where you have to maintain greater than 30% nameplate capacity, how can you guarantee that? Or 50% nameplate capacity for 30 minutes and 75% capacity for 60 minutes. How can you do that? You might be able to do that with some of the plant loading, but you would need to have a load bank to be able to test the desired loads for the required amount of time. So it's easier with the load bank than without. What communication protocols are you? Okay, communication protocols, you can have Modbus, you can have any communication protocol, even HTTP. So the particular example that we showed here was with HTTP, because you could be able to log into this site with your phone and make all the necessary changes you want. Okay, Raul, thank you for the email. Okay, let me see if I can. Okay, so maybe I mentioned that this question is from Yelp. Is there a load bank provides AC DC? It's more difficult to have. I think you're asking if you can combine AC and DC, and the issue there becomes how do you cool it unless you have an external cooling system. So there are not very many cooling motors or blowers that have both AC and DC operation unless you have an external supply. So the question is, can you have a combined AC DC load bank? I guess you can, but you'd have to make sure that the contactors for the control can handle both the AC and DC currents and voltage. That seems to be a little difficult sometimes. And the cooling system has to be compatible with both. Or you're going to have two separate motors, two separate sets of loads. It becomes more difficult. Do we have a size range of load banks we can offer? We do. We have any size you want, from 100 kilowatts or 50 kilowatts to 4 megawatts, AC, DC, 480 volt, 240 volt, 120 volt, 5 kV, 13.8 kV. Anything can be simulated in this system. Do I have load banks to regulate frequency and voltage? No. I don't know. No, I don't have. You would need a power electronic load bank to regulate the frequency, although the frequency is more dependent on the source and the load, right? So I don't think we can do frequency and voltage. No, we can't. We can't regulate frequency and voltage right now. Can I-Gard provide medium voltage 4160? Yes, we can. Copy of the presentation. Yes, a copy of the presentation will be sent out. Also, a recording will be sent out with the would be available online, so you can listen to this again. The voltage is adjusted as we have the same. Voltage is adjusted so we can use the same load bank 480. Yes, again, okay. Can we use the same load bank for 480 and 600 volts? Yes, you can, and there's two ways of doing this. One is to adjust the load so you get the same wattage output for the 600 and 480 volts. The other method is to keep the load bank consistent, and the 480 volt will be 64% of the wattage of the 600 volt. Can your load bank simulate motor controlled by VFD? Sure. Well, I don't think I understand. Can your load bank simulate motors controlled by VFDs? I'm not sure. Bill, Bing, if you can send me an email, I'd appreciate it because I don't think I fully comprehend your question. Simulate motors controlled by VFDs. Is it possible to integrate the load bank with a SCADA system to monitor efficiency? Yes, it is. We can provide all the outputs you require to monitor which contactors are closed, when to start. So the normal process is you start your generator and you have voltage on the load bank. Then you can start playing with the load bank loads, and you can do that through any means. If you can, you certainly use a SCADA system to do that, and you can monitor fuel capacity, fuel discharge, exhaust temperature of your generator. You can also measure exhaust temperature of the load bank and load profiling, and you can do all that with the SCADA system. As long as you have all the sensors available to do this, you can monitor everything you want. For Willie, we don't provide the cables. Again, we sell a lot of the load banks. We're not a rental company. There are a great many rental companies that will rent you the load bank and the cables to go with it. So you can talk to them and use our load bank with their cables and cam locks, and they come with everything you want. So can load banks communicate with other manufacturers, load banks that are not, or that are networkable? We haven't really figured that part out yet. Some protocols are easier to navigate than others, but I'm sure if we had the communication protocol and bitmaps, we can certainly do it. It's just a matter of getting that information. For medium voltage, this is a question by Leo. Do we have transformer type or direct connected type? I assume this is for medium voltage connections. We've worked with both. So you can have a 600 volt load bank connected to a 4160 to 600 volt transformer and test the 4160 volt side. Depending on how many steps you have, you may be able to go with 4160 volt directly and have medium voltage contactors change the load profile. So we'd have to look and see the combination of contactors, whether it's easier to do at 4160 or at 600. So we have done both transformer type and direct connection with medium voltage pickup. How much does the slide equipment weigh? Oh, this one's it's not very heavy. I think it's about 200 pounds. I don't have any trouble pushing it around on the wheel, so I think it's 200 pounds. But I'll double check and we could publish that information. Well, actually, we'll put this on our website, so the data sheet will be there. What are we doing with time? Devench?
We are good. We are done.
Does that mean we're good with time? I think I'm having an easier time with the questions than your answer. Okay, if you have any more questions, please send us an email, support@i-gard.com, and we'd be happy to answer the rest of your questions. And we will pick this up again at 1 p.m., right?
Yes.
All right. Thank you, everybody, for attending this short session. And again, the slides will be available. Do we give PDHs? Devansh?
Yes, they'll be able to download it at the end of webinar.
No, but the PDH as well.
Yes.
Professional development hours. Okay, thank you. Thank you very much, guys. And I sure hope Sonny's feeling better soon. Thank you very much.
Thank you, everyone.